Okay, so we're going to cover polynomial division today, and I forgot to pass this out, but here's your handout. There you go for this. Okay, and again, this is it. My job, I would normally give you a work day today, but my goal is to be done with this stuff because we actually don't have that much time. We have to turn in Chromebooks on the 7th, so you guys need to be done with the test, have retakes done, everything by the 7th. So I'm kind of pushing things up just a little bit so you can get done early if you want to. Say it again.
Is today the last day that you're doing?
Yes, this is the last instruction then for everything, okay? So dividing polynomials. Now this is one, when we're dividing by a monomial, that's easy. We already know how to do this, right? What would I do? Just break up the common denominator, right? I would write my common denominator separately in each of the three fractions. I just wouldn't write it as a common denominator. So this would just equal 5n to the 8th divided by negative 5 n to the 6th plus 15 n to the 7th divided by negative 5 n to the 6th plus negative 35 n squared divided by negative 5 n to the 6th. And I would just simplify each one of those. Well, what's that first term going to be? You just divide the numbers to get the coefficient. So negative 1 and then n to the 8 over n to the 6 would be n to the 2nd. So negative 1 n squared, negative n squared. How about this one? N to the 1, right? And then finally, how about this last one? Negative over negative is positive, right? 35 over 5 is 7. Now let's take a little shortcut on this last part. So look at this. N squared over n to the 6th. N squared is going to cancel 2 of the powers of n on the bottom, leaving me with a 4, right? Okay, make sense? So I get 7 divided by n to the 4th, right? Everybody good with that? Okay, make sense? Okay? So that's easy. Now what's a little tougher is stuff like that, where we're dividing by a polynomial that's not a monomial. Okay, so to get ready for that, we're going to just quickly review what we did way back in the day in grade school when we divided numbers using long division. What did we say? If whatever is in the top of the fraction goes inside the division bracket, and whatever's in the bottom goes out front. And then how did we do this process? Well, we would just look at the first digit and say, how many times does 3 go into the first digit of the numerator? Well, 0, right? So I got to scoot over to the next digit. 3 goes into 17 how many times? 5. Goes in 5 times evenly. And then what did I do? Okay, you multiplied, right? So I multiplied by what's out front. And I subtracted, right? And when I subtracted, 17 minus 5 was 2. And then I would just bring down the next digit and start over, right? 3 goes into 28. 9 times, right? Evenly. So 9 times 3 is 27. And then, here, let me go back and change that color for the notes. So 9 times 3 is 27, and then we subtract. 28 minus 7 was 1, and what did we call that 1? That's the remainder, because now that's smaller than what was in the denominator, right? Smaller than what is dividing into the original number. It can't go into that, so that's what has to remain. That's what remains over the denominator. So our final answer is just going to look like my 59 and the remainder was 1. and that's what remains over the denominator of 3. So 59 and 1/3 is how we would have said that back in grade school or in middle school, right? Okay, now we don't use mixed numbers anymore. So we know that 59 and 1/3 is really 59 and another extra 1/3. So it's 59 plus 1/3 is what we really mean by 59 and a third, right? 59 plus an extra additional 1/3. Okay, so we're going to do that same process with polynomials. Okay, just like we did with numbers, whatever's in the numerator goes inside the division bracket, but notice something. We included this extra term because we have to have a column for each power of x, right? So in this case, notice that we had a missing x term. So I need to include a 0x inside the division bracket. I must have all of the powers of x from my biggest power of x, which is x cubed, all the way down to the constant. So if I'm missing anything, I have to include a 0 coefficient for that missing term, okay? Now what is in the denominator is what goes out front, x squared minus 1. Okay, and I'm going to do this the same way I did before. I'm just going to ask how many times does the outside stuff divide into the inside stuff. But the good news is we only have to focus on the leading terms. Okay? So how many times does x squared divide into 3x cubed? Well, here's how we can find out. I'm just going to go up here and I'm going to write down the leading term in the top, or inside, divided by the leading term in the denominator, or outside. And what is that? What's 3x cubed divided by x squared? 3x. Okay, so then my first part of my answer is a 3x. Everybody get that? Okay, what do you think I do? If I get a term on top, I'm going to do just like what I did with number long division. I'm going to multiply by what's out front, so that means distribute in this case. 3x times x squared is 3x cubed. 3x times negative 1 is minus 3x. But I've got to line that up in the x column, right? And then I'm just going to subtract vertically, just like I did with numbers. Okay, when you do this, though, to avoid making a mistake, put a negative sign out front and put the whole thing in parentheses, because here's how you have to do this. Top minus bottom. 3x cubed minus 3x cubed cancels. Okay? Negative 8x squared minus nothing just gives me a negative 8x squared. And if there's nothing in the second row, you can always just bring it straight down, in other words. Okay, now be careful with this one. 0x minus negative 3x is what? Plus 3x. Subtracting a negative is like adding, right? So I'm going to get a plus 3x, and then I bring down the plus 11, and now I just rinse and repeat, right? Just do the same thing. So x squared times what is negative 8x squared? Negative 8. So we know the answer up here is going to be negative 8, and where we get that from is just negative 8x squared divided by x squared, right? So do you even really have to write that down? No, you can just ask yourself, x squared times what is negative 8x squared? And the answer is negative 8. Got a new term in my answer, so I distribute, I multiply. Negative 8 times x squared is negative 8x squared. Negative 8 times negative 1 is positive 8, so I'm going to line it up in the constant column. And then I subtract. Well, look what happens. Those guys cancel. I can bring the 3x down. (11 minus 8 is 3. And now, can I go any further? X squared times what is 3x? Doesn't make any sense, does it? Right? As soon as the power after subtracting is less than the degree of the denominator, I know I'm done. right? It wouldn't make any sense if I tried to continue this process up here. If I took 3x divided by x squared, right? That doesn't make any sense. Okay, I can't, x squared won't divide into x. So I'm done, and what do you think this becomes? The remainder. Okay? When I have to stop because I no longer can divide into what's left behind when I subtract, that means that's the remainder. Okay? The other clue that was the remainder is, look at the terms in my answer. It's just a polynomial, but the constant is the last hurrah for that polynomial. You can't go any lower than the constant, so I know I'm done, right? Okay, so then what is my answer? Okay, so my answer is then you tell me, what do you think? 3x minus 8, right? There's the polynomial part of my answer. Just like I got 59 when I did the number. Now I have to put this plus sign there. Plus, there you go, right? This is the remainder, so that's what remains over the denominator. And there's my answer. How about that? Not so bad, right? Okay. Does that make sense? Okay. Let's do another example. We just need to practice a little bit more.
We should do a simpler example.
Well, I wish we had time. Tomorrow we could do a little bit of that if you want to. But I just want to get through this stuff today. So let's try one of these. Okay. And really, harder or simpler, I mean, it doesn't really, there's no harder or simpler. It's the same process every time. So this might look harder, but actually this one is easier. You'll see why. It doesn't have as much, you don't have to do very much on this one. Okay, so what goes where? Here's my division bracket. Okay, top one goes in the division bracket. So what am I going to write? Okay. Am I done?
Plus 0x.
Good, because I'm missing an x term and I'm missing the constant, right? So I've got to put a 0x plus a 0 constant. Have to have each column, right? Okay, what goes out front?
4x cubed plus x squared plus 3 plus 5.
Okay, everybody agree?
Yep.
Okay, give me so far, 1 to 5.
5.
Okay, so far good. Okay, now what? Good. Perfect. So we only have to focus on the leading terms. And I'm asking the question, how many times does 4x cubed divide into 4x to the 4th? In other words, 4x cubed times what is 4x to the 4th? X. Everybody agree? So we get it, and I can write it up here if I want to as 4x to the 4th divided by 4x cubed gives me x. Okay, Carter, what do I do when I get a term up top? Yeah, I got to multiply, right, and subtract. So I'm going to distribute by what's out front. X times 4x cubed is 4x to the 4th. X times x squared is positive x cubed. X times 3x is positive 3x squared. X times 5 is positive 5x. And I'm just going to subtract vertically. And what happens? Well, those terms cancel, right? Those terms cancel. And now I'm not going to have to do any more steps, am I? Because look what I'm going to end up with. X squareds, which is smaller than x cubed. So this is going to be my remainder then, isn't it?
Wait, aren't you multiplying x by the first term?
I'm multiplying x. I'm going to distribute the x all the way through now.
Oh,
Okay, I got the x by dividing the leading terms, but once I get the x, I have to multiply it by the whole thing and subtract, okay? So then look what happens here. I get 6x squared minus 3x squared is 3x squared. And again, that's smaller than x cubed. It's a smaller degree than x cubed, so we're in the remainder now. 0 minus 5x is minus 5x, and then 0 plus 0, or 0 minus 0 is just 0, which I don't have to write. So there's my remainder, okay? So now you guys tell me, what's the answer? Okay, x is the polynomial part, right? X plus 3x squared minus 5x over my denominator, right? Okay, everybody good? Right? Okay. Okay, now this one, we're going to go through one more example, and then I'm going to show you a good trick. Okay, I'm going to show you a trick that works on some of these, but we have to be careful about choosing which ones. Okay, so one more of these, long division. Okay, be very careful here. You don't have to be so careful, never mind. So what goes inside? Okay, what goes out front? Okay, and we can probably be a little quicker with this, right? Because we're only comparing leading terms. So let's see here. James, x times what is 2x to the fourth?
2x cubed.
Everybody good? Okay. 2x cubed, I'm going to distribute. 2x cubed times x is 2x to the fourth. 2x cubed times 2 is positive 4x cubed. Now, what do I do? Caitlin, what do I do now? So after I multiply, I subtract, right? Okay. 2x to the fourth minus 2x to the fourth, those guys cancel. The first terms always cancel. 3x cubed minus 4x cubed. Negative 1x cubed. I'm going to bring the rest down. Okay. Riley, what's next? Okay. So x times what is negative x cubed? X times what is negative x cubed? Okay, positive or negative? Right? X times what is negative x cubed? Wouldn't that be a negative x squared? See what I'm saying? Does that make sense? Okay. So I'm going to distribute the negative x squared. Negative x squared times x is negative x cubed. Negative x squared times 2 is minus 2x squared. Okay, Caitlin, what do I do next after I multiply? Okay, that's what I asked you last time. So what was the answer to that? After I multiply and distribute, what do? I subtract. Good. I'm going to subtract that whole thing. Okay, so those guys cancel. Negative x squared minus negative 2x squared. What's that? You got to be careful. Positive x squared, because I'm adding 2x squared. And then I bring these guys down. I got to go again, right? Carter, next term, what do I do here?
So is what x? Isn't it just x?
Yeah, it's x, good, because x times blank equals x squared. Well, the answer, the blank, is just x, isn't it? Okay? So now I multiply, right? I got a new number or a new term on top, so I multiply and then subtract. So I distribute the x. I'm going to multiply by what's out front. I get x squared plus 2x. And if I asked Caitlin, she would now tell me I subtract. After I multiply, I subtract. And those terms cancel. Negative x minus 2x is negative 3x. Bring down the negative 8. and I go one more time, right? So x times what is negative 3x, everybody? Make sure, be careful. X times what is negative 3x? Negative, do you say negative? Maybe I missed it the first time. So negative 3. And now I'm done, right? Because I hit that constant. I distribute. Negative 3 times x is negative 3x. Negative 3 times 2 is minus 6. If I subtract the whole thing, look what happens. Those terms cancel. Negative 8 minus negative 6 is negative 8 minus negative 6. Negative 2, right? Because I'm adding 6, right? Negative 8 plus 6 gives me negative 2 for my remainder. And so what's my final answer then?
2x cubed.
Okay, 2x cubed minus x squared plus x minus 3 plus, I got to make my remainder fraction. Good, and negative 2 was my remainder, so that's what goes on top.
How much they adore your teaching.
Good, glad. And then on the bottom, x plus 2. Okay, there's my answer, right? It's a big answer, okay? That one took a while to do. Now here, check this out. I got a great shortcut for you.
Why would you give us a shortcut?
Okay, because it's a good question, but because it only works some of the time. Yes? No, we're not stopping. We're not stopping. No. We're not stopping. Heck no, we don't. We stop for no one. Okay, so here's the trick. Okay, so when you've got a really simple denominator, but only when you have a simple denominator, you can use a trick called synthetic division. So this only works when when the bottom is x plus a number or x minus a number. So in all the examples we just did, like if I go back, it would work on that one, but it would not work on that one because the denominator has got something bigger than x to the 1, right? And it's not going to work on that one. So it only works in a handful of cases, and this is one of them. Okay, here's how this works. Now you got to watch very closely. Super easy to do, but it's a process. So Jordan, Maddie, you guys got to watch this. Spark up. So when you're doing synthetic division, when the bottom is simple like that, x plus a number or x minus a number, you just make this big L-shaped bracket. That's the synthetic division bracket. And then you're only going to put numbers in this. There are no variables. Okay, you're going to put all the coefficients of the numerator. So 2, 3, negative 1, and negative 8. And you can't skip any columns. If there's a missing term, you have to put a 0 in for that coefficient. So then everybody see that's just going to be 2, 3, negative 1, negative 8. Okay, underneath the constant, we're going to make a remainder box. That's where the remainder is going to end up if there is one. Okay. Now this is a little tricky here, so pay close attention. The number that we're going to put out front is the 0 of the denominator. So what's the 0 of the denominator? In other words, what's the value of x that makes the denominator equal 0? Negative 2. Okay, now we're all set to go. We've got it all set up. Here's how you do the process. To get the ball rolling, you're going to take the first coefficient inside the brackets and you're going to drop it down below the bracket. So the 2 goes straight down, and that starts the ball rolling. Anytime a number appears below the bracket, you multiply by the outside number. So 2 times negative 2 is negative 4. You're going to multiply and send it up to the next column. And then you do the opposite of long division. Instead of subtracting, you add with synthetic division. So you multiply and add each time. 3 plus negative 4 is negative 1. What do I do with the negative 1? Multiply and get positive 2, and then I add. Negative 1 plus 2 is 1. Multiply and add negative 1 plus negative 2. Negative 3. Negative 3 times negative 2 is positive 6. And I add, and what do I get?
Negative 2.
Okay, I ask you, have you ever seen that number and those coefficients? How about that? Well, there's a reason. I mean, there's a way you can prove how this works, and it's not quite as tricky as it looks, but it's very convenient. So remember then, this is going to be this is the constant column. This is the coefficient of x. This is the coefficient of x squared. That's the coefficient of x cubed. That would be the coefficient of x to the fourth if there were a number there. You just work your way up in terms of powers of x, right? So then we could write this as, we know this goes with x cubed, so that's 2x cubed minus 1x squared plus 1x minus 3. Well, what do you know? That's what we got. And this is the remainder, so that's what remains over the denominator. So in 30 seconds, you can do what took us 10 minutes, right? Easy. Okay, but remember, this only works when the bottom of the fraction is x plus a number or x minus a number. So you tell me, thumbs up or thumbs down. Does it work there? Yes, it does. Does it work there? No, it does not. You got to use long division there, okay? How about that one? Yes. How about that one? No. Okay. How about that one? So honestly, there is a way you could make it work, but it's too tricky. So this year, we're saying no on that one. Because the bottom looks like 2x plus a number instead of x plus a number, we're saying nope, use long division instead, okay? All right, so let's get one more practice problem with this, and we're good to go. You guys we can get through this easily. Okay, so be very careful here now. Sam, what are the coefficients that I'm going to write in the bracket here?
1, 2.
No.
0.
How come 0?
Because it's for the x cubed.
Because I'm missing that x cubed, right? Notice there's, okay, whoops, does that make sense? We've got a, oh my goodness. Right? There. There's a 0x cubed because we skipped that term. So we've got to put a 0 there. What's next? 2. Good. And then that's where our remainder box goes, right? Okay, Riley, what goes out front? No. No. It's the 0 of the denominator. So Riley, what's it going to be? No, it's so let me say that again. So it's the 0 of the denominator, which is our math way of saying, what's the value of x that makes the bottom 0? So, well, no, so in other words, 2, that's it, right? So in other words, I'm just asking the question, what would x have to be? What minus 2 is 0? 2, right? Okay, does that make sense now? Okay. So now we start the ball rolling. Maddie, what do I do here? What do I do here to get this thing going? Okay, I drop the 1. Anytime a number appears below, Jordan, what do I do?
You're gonna bring it back up.
You multiply.
You gotta multiply it, and then you add.
Then I add. Good. So I get a 2. I multiply, and then I add. I multiply, and then I add. I multiply, and then I add. And that's the remainder box. So that's my remainder. And so look how quick that is. What's my answer?
X cubed.
Okay, so now there's a tendency people want to start on the left. Start on the right, because you always know that's the constant. So then that's going to be what? 6x, x squared. Okay, so I end up with, everybody agree, I end up with 1x cubed plus 2x squared plus 6x plus 10 plus what, Riley?
2.
No. 19 divided by x minus 2. Okay? Because the remainder is what remains over the denominator. Okay? Everybody, how are we doing? Give me 1 to 5.